In this video, I am going to demonstrate how to use the MTR tool to diagnose a network, or the network diagnostic tool. MTR simply refers to my threshold, and this is a very significant tool in determining if there are issues on your network or at the destination host. So first things first, this tool is run differently on different platforms. So, and as for Windows, you could download different other softwares that you could download to run the MTR tool. However, with Linux, which I'm focusing on today, and specifically CentOS, you have to install this tool simply using the yum utility tool, which is yum install MTR. Boom. So I run my installation utility, and what it shows me is that this tool has already been installed. So I have nothing to worry. However, if that wasn't the case, all you would have to do is to simply run that very command, and that would help you to install this tool on CentOS, on Fedora Code, on Scientific Linux, as well as a Community Enterprise, as well as the Red Hat Linux, because these are pretty much the same distros. However, if you're running Ubuntu, you'd run the sudo or apt-get install MTR, and that utility would simply help you to install the MTR tool. So in this case, anyway, I'm gonna run this tool to simply determine if there are issues between my source machine or computer or domain and the destination, which in this case is gonna be cisco.com. So I run my MTR tool, which is MTR command. However, I'm going to use switches to simply specify a report, to generate a report using the domain names of the different hops, as well as specify the packets that I need to be sent from the source to the destination. So I'm going to run MTR prefix RWC. The R simply for generating the report, the W for the wide naming of the domain name, and the C for the cycle reports. And my destination will be www.cisco.com. What I expect in the result is to give me the different ping connectivity tests, as well as the threshold that the packet, well, I haven't specified the packets. It's going to be 30 packets. So I want 30 packets sent from the source to the destination. So what I expect in return is that this command will simply run 30 packets from the source to the destination through different hops or through different routers. Bang. So we run our command. It might take a few seconds before we get return on this, but it should give us a return very soon. Gonna work, because obviously this goes through different routers or different hops, and so it might take a little while, especially when you specify the number of packets. There we go. So yeah, here we go. So what has happened here is that we've sent 30 packets from our source to destination, and deploy statistics. The destination is not quite familiar, so I might have, not because it hasn't produced any results, it's actually sent 30 packets from the source to destination. The only that I'd prefer that I did understand destination. So I'm simply going to run this again. Apologies for that delay. So I'm going to run with the same switches, which is RWC I already explained what that means, and I'll specify 30 packets. Well, let me just do 25 packets anyway, so just to make a difference between this and the previous one. Cisco.com being my domain name. Alternatively, you could specify the IP address of the destination. So yeah, we run that. Just give me some results. There we go. Well done. So yeah, that's more like I expected to see until it hits the Cisco.com destination. So what you see is simply a representation of the command that we've done. So what we've actually specified in this case, that we've sent 25 packets from our source to destination. So what I'm actually doing now, I'm just going to describe what each of those columns represents and what they actually mean, and how they'll be helpful to determine what you need to know and making out where the faults and where the issues are between the source to the destination. So the first column represents the hop count. The second column represents either the domain name or the IP address. The third column represents the packet loss. The fourth, packet sent. 25 packets have been sent. The column named as last simply represents the round trip time for the last packet sent. The average packet, the best round trip time for the best packet sent. The shortest, meaning the best, and the worst round trip time taken, which is 0.3, and the standard deviation for the last column. So in this case, what you have to look out for, what we can see is we're actually pretty good between the first hop count to the 10th hop count. We cannot see any packet losses between those. And so if you have been having any issues along the way, or there's been a high latency, what we can tell from this is that we've sent 25 packets, and between the first and the 10th count, it's all looking good. However, we begin to see a packet loss on the next 3 hops, which is 100%. That would actually represent sort of a ICMP denier, in that some people would deny ICMP or rather pinging their IPs, and so that's what you see right there. That could contribute to some latency issues sometimes, but however, not so much. What we also see is that we're not seeing any packet losses between the 15th and the 16th, but we again see some packet losses at the 16th and 17th. So this is at the very last count. There's a packet loss of 4%. However, the 25 packets have been received. We can see some latency issues. These are probably as a result of some ICMP issues, or ICMP not being able to ping those IP addresses, or some configurations of their router. That's what we have in these 4% packet loss. But that's fine. That's pretty good. So if it was anything over at 10%, there'd be something to worry. But simply 4% doesn't really kill so much. And so in the packet losses, it's a very determinant column to look at. The packet sent, not really. That is simply for your ISP to show that you've sent the same packet count and how the different hops manage or those 25 packets. And the other column to look at would be your simply the best round trip time taken and your worst. And if that is not rather high, so the standard deviation will also be low, and so that's a good thing. However, if there was a high standard deviation, then there'll be cause for worry, and you simply have to re-examine your worst and best round trip times taken for the packets through the different routers. However, if that wasn't consistent, or rather, if there is a consistent with your average round trip time taken, then there isn't much cause for concern, especially at the first three hops, because those would represent your ISP. And the last ones would the last three hops, which is 17, 16, and 15, would represent, in most cases or usually, your host destination, or destination host, or the destination. And so if you had any issues in between 4 and 410, then, or rather 4 and 10, then you'd have to worry, because then you have no influence between the other parent partners or ISPs. So you'd have to hope that they sort their issues out so that you can get some good latency, or rather low latency, between the rather packet propagation. And so that's generally how you use the diagnostic tool. It's a very important tool to give you a proper reflection of how the packets are being sent from your source to destination. If one of the hosts had some issues, you'd perhaps be helpful to run this tool on other hosts, see if they're still having issues to the destination. If there was a difference, then you'd pin it down to know that, okay, rather the issues could be at your end. But however, if the issues were down the road and there was a high latency or high standard deviation, then there would be a high, rather, cause for concern that perhaps the ISPs or parent partners in between have got some issues, and you have no bearing or influence to when things are going to be sorted out. Yep, so generally that's it. And if you like the video, if you think it's been a proper guide to what you want or what you've been looking for, you can simply like the video and on the channel. Otherwise, thanks for checking in.